Okay, today we proceed. Can we proceed our sharing session now? Class, can we proceed?
Yes,
Yes,
madam.
madam.
Yes, madam.
Okay, right. Okay, thank you. Okay, today we will cover our second part from our subject. Okay, our second part is more on more on the control system. Okay, more on the control system. So from the slide, this is all the introduction. Is it? This is all the introduction about the control system. Okay, so when you see the second slide, okay, upon completion for this topic, supposedly what will be covered actually for today. Okay, so once completion this topic for this morning, so should be everybody the rest of students should be can define what is the control system. Okay, you also can differentiate between open loop and closed loop system. Okay, and then the next, supposedly you should be able to identify some application of the control system. Okay, this is our checklist for today. Okay, okay, here is a few definition. What is a control system? Okay, so from the definition, meaning system is a structure. Okay, system is a structure defined by parts and their composition. Okay, and the overall, what is the control system? Is a okay when this one control system. What is the control system? Okay, control system is an arrangement. This one I highlighted. What is the control system means? Okay, the control system is an arrangement of subsystem and plant or sometimes they call process in which physically connected or assembled for the purpose of controlling, directing and regulating the output. This is why we need the control system. Okay, why we need the control system is we need the control system for what purpose? Controlling, directing or regulating the output. Okay, this is why we need the control system, right? Okay, this is consider a bit definition about control system structure. Okay, this is on the control system structure. Meaning this is a differentiate between the open loop and the closed loop. Okay, when we see from the open loop, they don't have a feedback element. Okay, this is a feedback element. What I'm talking just now, this is a feedback element. Okay. For the control loop, they don't have the feedback element. Okay. So this is our first and this is our second. This is a two type of the control system. The first one is a open loop and then the second one is a closed loop. Okay, that's a difference between open and closed, right? Okay, now you can see from the slide. Okay, here from the slide, what's the difference between open and closed? Is this What's different between open and closed from the block diagram? Okay, between open and closed, the open loop is a direct measure. Okay, when we set the this one, we give the desired output response or input, okay, to the control system, and then we can get the output. Okay, we set the desired output response through the control system, and we can get the output. That's a closed loop control system. But for the for the open loop, another one is for closed loop. From the closed loop, you can see we have a few block diagram represent to what? Okay, for the closed loop, we have a few of the block diagram that represent for the input transducer. They represent the controller, the actuator, the process or the plant, and then another one is a feedback element. Okay, or from that slide you can see feedback element or this one output or transducer. Okay, meaning we use output or transducer as a feedback element in closed loop control system. Okay, and then this is the output. The output we control from the whole system. Okay. Okay, this is a definition of all the element from the closed loop system. Okay, input. What's meaning input? Input is also called desired value or set point. Okay, and the output is our actual value. Okay, the first one output. Output is our desired value or acentra or set point. And then the output is our actual, okay, or,
Response.
or our measured value. And the controller, what's meaning about controller? Controller is a device which monitor and affect the operational condition of a given dynamical system. Okay, this is all the definition about the our overall block diagram for the control system. Okay. And then another one is an actuator. Okay, from the block diagram itself, from the from the closed loop block diagram. So this is all the definition. The input, controller, actuator, process, and the feedback element. Okay, actuator. What's the definition about this actuator? Actuator is a mechanical device for moving or controlling a mechanism or system. Okay. Actuator convert the control signal to a power signal. Okay. Okay, example actuator or sometimes they call final control element. Yeah, final control element. Okay. Actuator or final control element. Normally in the process you can find out motor, DC motor, and valve. That is our control element part. Okay, or our actuator. All right. Example from here, you can see from the mechanical. Okay, from the mechanical device, they show here the pneumatic actuator, electric motor, and acentra. That is one of the. This is the example for the actuator from the mechanical devices. Okay, and then last one, the process or the plant. What's the definition for the plant or process?
Combination of process and actuator.
Yeah. Plant or process is set of mechanic parts functioning together to perform a particular operation. Okay. The combination of process and actuator part of the system to perform a particular operation. Okay. Example, process of the plant is a heating furnace, spacecraft, and the chemical reactor. Okay, meaning the process is the where the process is happen. Okay, that's we for the element represent for the process. Okay, where the process is happen. Okay, after this we can see a few example related to the closed loop control system. Okay. Okay, this is transducer is our feedback element, right?
Yes.
Okay, let's say we have this system. I give you the example of the feedback or the closed loop. Okay, okay, this is your input. Okay, this is your output or your actual value. Your input is
Yes.
your desired input, and then the first part or the first block is a controller. The second block is the actuator. The third block is the process or plan, and the last block, and then the output.
Feedback
When the
element.
output, okay, when the output, the feedback. This is the feedback element. Okay,
Yes.
okay. The feedback element is the transducer. Okay, a device that is actuated by the power from one system and supply power usually in another form. Okay, meaning transducer or the sensor. Okay, this is a feedback element from the closed loop control system, right?
Yes.
Okay, now we can see from our case study. Okay, what we talking just now, the closed loop control system. Okay, let's say we have this kind of the system. Okay, example, I give you this is our system. Okay, the system is, what is the system? Okay,
Close.
okay, the system is, hold on. The system is, we want to control the position of the antenna. Okay, we want to control the position of the antenna. Okay, control the position of the antenna. Antenna, A N A. Okay. We want to control the position of the antenna. Okay. From the system, we represent into the block diagram. Okay. The first is the actual system. Okay. Whereby the system is represent how we want to control the antenna. Okay. And then the second system is the we represent the actual system into the block diagram. Okay.
Diagram.
Okay. When we see the uh, first block diagram, okay, the first block diagram meaning this is the input. transducer. Okay, this is the input transducer. Okay, this is the input transducer. Okay, when we see from the block or from the system, okay, where is our potentiometer from the first system? Okay, this is our potentiometer. Okay, potentiometer is our input transducer. Okay, and then we have another one potentiometer here. Okay, okay, from this system, we have two potentiometer. The first potentiometer, okay, this one. The first potentiometer is represent our input transducer, okay, and then the second transducer is our output transducer, okay, meanings, and then from the system also we represent into the block diagram. You can see the controller, okay, the controller, actuator, process, okay, and then our output transducer, and then this is our input transducer, okay. Now the second block is a controller. Controller is normally is the electrical part, okay, or electrical circuit. Okay, from here, our electrical part from the system is this one, okay, differential amplifier. This is our controller. So we represent into the block, and then you have to label controller. You label with this one, okay. You label with the from the from the actual system, you label into the block diagram, okay, and then you label with this one. You label with differential amplifier and power amp, okay. Actuator. So you see from the part, or you see from the system, motor is our actuator, okay. Motor is our actuator. So you label here, this is our motor, okay. And then how about the load or gear, okay. This is your gear, okay. This is a gear, they represent two gear here, okay. Gear is our process, okay. Gear is our process, right. And then you label under process, okay. And then the last one, you can see this is our output actual angle, meanings position. Position is we want to control the angle, okay. The system is to control the position of antenna, meaning we want to control the angle, okay. So meaning our input, you can see from here, this is our input desired angle, meaning we label with the theta I, meaning you can see from here, this is our theta I, okay, this is our desired angle, and then the output is we label with the theta naught, meaning for angle output, okay. Okay, now this potentiometer, okay, this potentiometer, the second potentiometer, we want to measure the angle, okay, we want to measure the angle, the second potentiometer, this one, okay, the second potentiometer want to measure the output angle. So that's why this is our output, okay. And then our feedback element measure the output, okay. Here is the angle theta, okay. The output potentiometer will measure the output actual angle and send back into this one. This is we call summing point. Okay, this one is we call summing point. Okay, You know the potentiometer during we study transducer, okay? Potentiometer, there will be convert displacement, okay? You remember this is the diagram of the potentiometer, meaning this is R1, this is R2, okay? We want to measure, this is our what? Our wiper, okay? So meaning we adjust the wiper, this is the angle, okay? This is the angle. So meaning we adjust the wiper with a certain angle, so we can get what's the output here. Okay, this is the output. Alright. So meaning we give the input represent as the angle. Let's say it's a theta I, and then we can get the output is a voltage. Okay, this is a potentiometer. Potentiometer, the input is an angle or displacement. Okay, it's a displacement, and then we can get the output is a voltage, meaning we get the output is on the electrical signal. Okay, electrical signal, right? Okay, are you with me, everybody?
Yes.
Yes, madam.
Okay, can I see the our attendance? We have a 20 here. Okay, Aisha is here already. Aisha.
Hi, Madu.
Muncul tak tertidur kan? Okay. Abang Long ada Abang Long? Abang Long ada? Din ada?
Ada.
Okay, so everybody, your internet connection, is it okay until now?
No, at
Yes,
all.
madam.
Not at all. Okay, hopefully. Try your best, okay? Try your best with the internet connection, okay? But for this lecture, um, I prepare the video recording, and after this, I will share to you to refresh back, okay? What our sharing session, okay? You can refresh back and you can refresh many times to understand what we share today, okay? Okay, now, until now, so far so good.
Okay.
How everybody?
Okay.
Okay, still can follow. Okay, right. Okay, let's say this is our second example. Okay, this is our second example. This is a turntable example. Okay, this is our system. Okay, figure one is our system. Right, our system is they want to control, the system is to control the turntable speed. Okay, you see, this is the speed. We want to control the speed of turntable. Okay, so meaning control speed of turntable. Okay, the control system is to control the speed of turntable. Okay, meaning what's our input or what is our desired speed? Okay, what's our input? What's our input or our desire input? Okay, this is our input, meaning we want to control, the system is to control the speed. So meaning speed is our desired, or speed is our set point, or
Set.
speed is our desire input. Okay, so we label at the input part, we label with this one. We label this desired speed is our input. okay, our set point. Okay, from here you can see okay, you see this is our speed setting, okay, meaning our input, okay, and then the second block is our DC amplifier, okay, DC amplifier is our controller, okay, the first one is our system, okay, this one, the first figure is our system, and then the second figure is our functional block diagram. Okay, we represent our system in two blocks, right? So now, after DC amplifier, you can see motor. Okay, motor is we represent as actuator. Okay, and then the last one, what is your process or plan? This one, your plan is turntable.
Turntable.
Yes, good. The plan is a turntable, meaning where is the process happen? Okay, this is our process or our plan. Okay, and then what is your output? Output is a follow what is your setting as your input. Okay, meaning your input is a desired speed, meaning your output is the actual speed. Okay, actual speed. Okay, for the first circuit or for the first figure, this is our system represent in open loop. Okay, in open loop, we represent our system in open loop. And then when we, how we want to design to make it open loop can represent into closed loop. Okay, you have to add on what? You have to add on,
Feedback element.
yeah, you have to add on feedback element, or you have to add on a transducer to measure speed, to measure your actual speed.
Yes.
Okay, so we add on another element is, you can see here, tachometer. Okay, tachometer is to measure what? To measure speed.
Speed.
Okay, so we add on the tachometer as our feedback element here to measure this one. Okay, and then tachometer will measure speed. Okay, this is the speed. And then the tachometer will measure speed and convert speed into voltage. Okay, that's the tachometer or the transducer. Tachometer, the speed is the input. Okay, let's say like this. Okay, this is your uh, tachometer. And then the input to tachometer is the speed, and then the output is voltage. Okay, so tachometer will measure actual speed and then convert into voltage, and then the signal sent to this one. This is sometimes we call comparator. Comparator or summing point. Okay, comparator or summing point, right?
Madam,
So, yeah,
what is the main purpose of the summing point or the comparator?
meaning the comparator, they will compare the input, they will compare this element, the comparator element or summing point element will be compare our input voltage and the output speed measured by the tachometer, and we can get the error. So meaning the,
Okay.
okay, is it clear?
Okay. Yes, madam. Thank you.
Okay, right, good. Okay, meaning the comparator will be compare the desired speed is our input. Okay, this is our input, and then compare with the actual output and then get the error. What's the error here? And then the process will be looping to get the actual speed very close to our desired
Uh,
speed. Okay?
so, madam, if
Yes,
you want to
yes,
test
madam.
the efficiency, you
Yeah.
just check the summing point or the comparator of the system.
Yes, correct.
Okay. Thank you.
Okay, right. Okay. This is just a clarification of the control system. This is we share the previous our system, the control the antenna, meaning this one is without what? Without the feedback element. Okay, this is just for the open loop without the potentiometer. We only have one potentiometer here as the this is as our input. Okay, here this is the input transducer we use the potentiometer as the input transducer, but consider this figure show the open loop. Okay, show the open loop system. Okay, this is just a bit explanation what is the open loop system. Okay, system which utilize an extracting device to control the process directly without, they mention here, without feedback, okay, without using feedback. Okay, this is the open loop. Okay, a system in which the control action is independent for the output signal. Okay, for the output signal. Okay, an open loop system operate without feedback and directly generate the output in response to an input. Okay, example has our home appliances like a toaster. Okay, meaning toaster is one of the example for the open loop control system. Okay, meanings the system operate without feedback and they directly generate the output in response to an input signal. So from okay, I show you the example for the toaster. This one. Okay, this is our example toaster. The toaster is the open loop control system. Okay, what is our input? What is our input? Our input is we need the color toast.
Color of the toast.
Yeah, this is our input here. Okay, this is our input. We need our desired color of toast, and then your output is what is your actual color of toast. Okay, meaning your actual is explanation is very close to what is your set as your desire. If your desired color of toast, meaning your output is your actual color of toast. Okay, and then from here, what is the controller? Your controller part or your controller element is a time regulator, meaning when we use your toaster, you will be set the timer, right? That's your controller parts. Okay. Everybody know how to use toaster, experience to use the toaster. Can you imagine how to use the toaster?
Yes.
Okay.
Yes.
Okay, the first when you switch off the power, okay, first you have to set the timer, is it? But your expectation what? What is your expectation? You need the color of toast, right? You want light, medium or darker, right? This is your expectation. That's your desired. Okay, so you set that's your input. Okay, what is your input? Meaning, I want the toast is a dark. So you set the color. You already set in your mind. You need what type of the color of toast? Okay, you set your timer. Meaning you set about 5 seconds or you set 10 seconds if you need your toast is darker. Okay, that's your controller part. Okay, what is the actuator element? Inside the toaster. Okay, meaning the heater. Heater is your actuator or your final control element. Okay, meaning when you set the time regulator, the heater will be working. inside the toaster. Okay, meaning where is the process happen? The process happen is inside the plant. So now what is your plant? Your plant is the toaster. Okay, everybody?
Yes, madam.
Yes.
Okay, okay. Okay, that's how to we want to present our system into the block diagram. Okay, first you have to set what is your desire and what is the input you want to control. Okay, so meaning from here you want to control the color. So we set the color is our desired input, and then the actual is a follow what is your input, and then the controller. The first your action or your taken action is the you set the timer. Okay, and then when you set the timer, the heater will be working. Okay, and then where is the process happen? Meaning inside the toaster. Okay, this is the way how you want to represent system into the block diagram, right? Okay, let's see the second example. This is also the open loop. Okay, fan, ceiling fan. Okay, ceiling fan. What is your desired? You mean the speed, right? Okay, you need the speed of the fan. Okay, so we set the input. Input is your desire. Okay, you need what is your desired fan speed? That's your input. Okay, and then you set the setting regulator, meaning this is the controller part. Okay, and then from there, when you setting the regulator, your motor, your electrical motor will working. Okay, and then you can get the outcome after the actuator working. So you can the signal we send into the fan. Okay, this is your plan. This is the process where uh, the process is happen. Okay, so in your fan blade, okay, your output is you follow what is your desire. Okay, meaning you can get the actual fan speed. Is it everybody? Are you okay? You can follow me?
Yes,
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 Okay.
madam.
madam.
Okay,
Yes,
good.
yes, madam.
Okay, okay, the next, this one, example, rotating this in CD player. Okay, first, what's your aim? To design a system for turntable speed control that will ensure the actual speed of rotation is within an acceptable percentage of desired speed. Okay, example or device is we using turntable speed control, meaning example turntable speed control is a CD player or computer disk drive. This is the example of turntable. Okay. Okay, this one. We have a turntable here. Okay. So now what is your desire? What is your input you want to set? Meaning, uh, we want to control turntable speed, right? So meaning we set our input is this one. Okay, we set this one. Our input is a desired speed. Okay, and then the amplifier is the controller. Okay, this is the controller part. Okay, and then you see here motor. DC amplifier we send signal into motor, and then your motor will be operate. Okay, your motor is the third element as a actuator or as the final control element, and then the DC motor will send the current into plant. Okay, okay, this is DC motor signal signal from DC motor will feed into the process, and then the turntable will be rotate. Okay, and then the turntable will be rotate, and then you can get the actual speed. Okay, but from this example or from this process, this is open loop. You can't measure the actual speed. Okay, that's why they call this is the open loop. Okay, this is the open loop. Okay, how we want to improve? Instead of open loop, we change our system into closed loop.
Yes.
How we want to add on to measure the speed from for this example? So you have to
Add.
include feedback element. Okay, what type
Yes.
of feedback element? So you have to what element you have to include into the system to measure the speed. Okay, what element we want to measure the speed? Okay, from here
Yeah.
we have to include transducer. Okay, meaning this is example measurement element. Okay, this is a measurement element to measure the actual speed. Okay, so you have to choose one type of the measurement element to measure speed and then send back into here. So you have to put the comparator here. Okay.
Mm.
Okay, what type of measurement element here to measure the speed? Let's say we use,
Tachometer.
yeah,
Meter.
good. Yes, very good. We use the tachometer, okay, to measure speed, and then we can get the output from the measurement element. You can get the voltage signal. Okay, that's the way how we want to, uh,
Improve.
yeah, how we want to do the modification from the open loop into the closed loop. So you have to introduce measurement element and what type of measurement element you want to use to measure speed. So you have
Uh,
to, yeah, we have to include the tachometer to measure the speed. Okay?
okay.
Okay, everybody can follow. See now, so far so good.
Partial good.
Okay, good.
Yes,
Okay,
madam.
this is the overview for the what for the disk drive. Okay. Okay, like we come back to this system. Okay, just now this is the system is to control the position of the antenna. Okay, so meaning here how we want to control the angle. Okay, this is the angle of the antenna, theta naught. Okay, and then the input to this system is a theta I or angular. Okay, the angular displacement, because when you see the gear, okay, gear is the output from the gear is an angle, right? Okay, the position of the antenna, sorry, the gear. Okay, this is the gear. Okay, this is the gear. Okay, gear will be rotate based on uh motor. Okay, motor will be rotate the gear. Okay, that's why we need this transducer. We need potentiometer. Okay, potentiometer as our output transducer to measure angle. Okay, and then you can get voltage here. Okay, from here you can see advantage of the closed loop. Okay, what is the advantage of the closed loop? Less sensitive to noise. disturbance and changes in environment. The same. Okay, what we're talking just now. Okay, advantage, high repeatability, increase the accuracy, increase the bandwidth. Okay, these are the advantages when we use a closed loop. Okay, what the disadvantages? Of course, because of the complex block. Okay, meaning it's just costly, right? This one, because of the complex construction, and then of course expensive. Okay, for the closed loop they have a problem for the stability. Okay, there's a problem on the stability will be created when we use the closed loop system. Okay, and then another disadvantages is we have to train the operator to operate the system. Okay, this one required, meaning we need the trained operator to control or to operate the system, right? For the closed loop. Okay, this is considered a comparison between open loop and the closed loop. Okay, for the closed loop, sorry, for the open loop, of course, simple and low cost and very stable. Okay, quite stable for the closed loop because they don't have the feedback element. Okay, and then the disadvantages cannot compensate the disturbance. Okay, if you can recall back when we use the toaster, okay, you cannot compensate the disturbance, meaning what you set the first process, meaning you can get the output. If you're not satisfied with the color toast, you have to resetting your time regulator. Okay, that's the meaning you cannot compensate the disturbance. Okay, that's the disadvantages when we use the open loop system. Like this example, sometimes not accurate. Okay, you have to recalibrate. Okay, you have to recalibrate. This is the disadvantages of the open loop. Okay, you have to set back your toaster to get what is your desired color toast. Okay, okay. When you see here for the closed loop is the closed loop. The advantages of the closed loop, they can compensate the disturbance because they have the feedback element. Okay, when they have the feedback element, the result or the output is a more accurate. Okay, but the advantages is a costly. Okay, and then the problem is a stability. Okay, the system is not stable because of the feedback element. Okay, class, you still can follow.
Yes, madam.
Okay,
Yes.
very good.
Yes, madam.
Okay, okay, this is another
Yes.
example. Okay, this what type of the system? We want to control the travel or the cost of travel. Okay, we want to control the cost of the travel. Okay, where let's say we want go to, what is the our cost? We want go to UITM. Okay, we want go to UITM. Okay, that is your expectation. Okay, meaning you have to set here. You have to set your desired cost of travel. Okay, meaning you want go to UITM. Okay, so meaning controller. Controller is the second element. Okay, or the second part. So now, who's the controller here? Suppose you as a driver. Okay, you will control the whole process. Okay, so we represent here is a driver. Driver as a controller element. Okay, and then how to control the travel? You use the steering. Okay, you use the steering to control your course or to control your target or to control your desire. Okay, So, and then where the process happen in your system, in your automobile system. Okay, that is represent of your plant. Okay, and then output. So how to see what is your actual, what is the actual output? Okay, how to measure back your actual? Is it your traveling is true or not? You want to go to your ITM, so you have to measure. So what's how you want to measure? You use based on your visual or based on your eyes, is it? Okay, based on your eyes to measure, is it your actual cost of travel, go to a UITM or go to ICT? Okay, example, okay, right, class?
Yes.
Okay, okay. That's the way how we want to present system into the block diagram. You have to present the first step is you have to present your desired cost of travel. Okay, the second part you have to represent what is your controller element. The third part, what is your actuator? The second part is plan. Okay, the fifth, is it that your actual cost is the same or not with your desired? Okay, and then how to make sure your actual is to follow your desired, you have to provide the feedback element. Okay, so what is, you have to represent what is your feedback element. So for this case, you have to use usual, okay, to measure your actual, follow to your desire. Okay, class? Okay, that's
Yes, madam.
Yes, madam.
Okay, madam.
any question so far?
No.
Okay, okay, good. Okay, this is same with the previous discussion. We want to control the rotating disc. Okay, we want to control speed of rotating disc. So meaning that's why we put our desire is speed. Okay, and then what is the controller? Controller is this one. Okay, the third part is what is your actuator. So our actuator is our motor. Okay, and then what is the, where is the process? Where is the process happen? Meaning inside the rotating disc. Okay, and what is your actual? Actual is you follow what you set as your desired. Okay, this is your actual speed. And then how to measure your speed? We use item or element number 6. We apply or we use tachometer to measure the speed. Okay? Okay. So, okay. Who can discussion? Okay, we open to discussion. Okay, identify whether the system is open loop or closed loop.
Close loop.
Closed loop. Okay. So Mio said this is the this example is a closed loop control system. Okay. So can we draw the block diagram? Okay, what is the process? The process control is to regulate or maintain the value of some quantity output to close to the set point. Meanings we want to regulate what? Okay, when you see this is, we have a tank, okay, and we have the, this is, oops, sorry. Okay, they provide here inlet means the water example. Okay, the inlet here. Okay, and then they show here they have a level measurement. Okay, and they show the controller. They show the IP converter and they show the control valve, and then this is the outlet. Okay, this is meanings your output. Okay, so what is your desired input for this system? What is your desired input for this system? Who can share the answer? What's your input? We have to set the input first. The step 1, you have to set the input or desired. What's the desired input?
Level of water.
Okay, good. Level of water. And then what's the second part or what is second element? The second element is a controller. What's the controller here?
Controller.
Okay, controller juga. Controller also. Okay, what's the third element? What is the third element? Our actuator. What is the actuator here?
Control valve.
Yes, very good. Control valve. Okay, meaning the control valve, we control the opening of the valve. Okay, we control opening of the valve, control opening of control valve, meaning you can get the volume of the outlet of the water, right? Okay.
Yes.
Okay, so very good. How about number 4? Where is the process happen? Where is the process happen?
Tank.
Yes, very good. Thank. Okay, that's number 5. What's number 5? What's the number 5? Actual. What's the actual? Actual output. What's the actual output? Actual
I
output. Actual output is very close to your number 1, your desire.
Level of water outlet.
Yeah, good. Okay, the first one is your desire level of water, is it? Okay,
Yes.
your number 5 is same with the
Actual.
actual level of water. Okay, that's your number 5. And then how we want to measure, because just now Mio said this system is a closed loop. Okay, what element we use to measure this one? We want to measure actual. What type? What the feedback element here? We want to measure actual level of water. Sorry?
Level measurement.
Yes, very good. We use this one as our number 6. Okay, this is our feedback element. Okay, so from here, you already list down all the item and then you have to draw the block diagram. Okay. Okay, this is the block diagram just now. Okay, but you have to represent your set point, what's your output, sensor, controller, your control element, and your process. You have to rewrite back the set point just now. Okay, you just write back what you have set
Madam,
point. Yeah.
Madam, what is the use of IP converter in this presentation?
Sorry.
The,
Can sorry. Your voice is not clear. Can
I
you?
mean,
Yeah.
the use of the IP converter that we
IP,
use
oh, IP
nowadays.
converter. Okay. Okay, the controller is a IP converter, meaning your controller part is um this one. Okay, this is your controller part. Okay, controller pass with the IP converter. This is okay, very good. Okay,
Thank you,
this is
Madam.
yeah. Okay, this one. Controller part. Okay, we put controller and the IP controller is your controller element. Okay, the signal sent to actuator, meaning your actuator is your control valve. Okay, control valve, we send signal into the tank. Okay, and then you can get the actual output of your water level. And then how you want to measure the water level? We use the level measurement. Okay, to measure the actual level of water. Okay, so this is a similar the block diagram, and then you have to label just now what is the controller, your control element, process, output, your set point, and what is your sensor. Okay, you have to write back into the block diagram. Okay.
Yes.
Okay, this is a few of the example on the control system. toaster, fan, aircon, aircraft, and then rocket launcher, right? Okay. Okay, this is the example when we're talking just now. We want to control the antenna position. Okay. Okay, this is our case study number 2. Who want to share this one? Oops. Oh my God. Okay. Who want to share the... Is it the slide clear?
Yes.
Yes,
Yes.
madam.
I make it bigger. Okay. Schematic diagram of water level control system. Okay, and the water level is measured by means of a float and a lever from the mechanical input, the amplifier, and flood the signal and power amp. Okay, who can give the answer for the input or set point? What is our input here? Input parameter or desire? What is the desire input here?
Green.
Sorry? What's our desire? What is our desire? This one, our input. What's our input for this system?
Water level.
Water level. Okay, this one. Okay. Water level. We want to control the water level. Okay, meaning the output parameter also same with the input, right?
Yes.
Okay.
Yes.
Okay, and then from the schematic or from the system, we find out the controller. Where is the controller? What is the controller here?
Pressure regulator.
Sorry,
Up
repeat again.
the valve.
The controller.
Amplifier.
Yeah, amplifier and the power
Power
amplifier.
amplifier.
Yes, very good. Okay, this is the controller part. Okay, this is your
Yes.
controller part. Okay, the second part, actuator. Where is the actuator?
It's in the
Regulator.
regulator and
Yeah,
bulb.
and valve, is it?
Yes.
Yes.
Okay, this is your actuator. Okay, and then process.
The
Brain.
tank.
Tank.
Sorry? Okay,
Tank.
good.
Tank.
Okay, right. Tank is your process or plant. And what's your sensor for this one?
Flow.
Level.
Inflow rate.
Level.
Sorry?
The flow.
Yes, very good. Float is your feedback element of your
Yes.
sensor. Okay, the float will be measure a level. Meaning this one? A float,
Yes.
okay, will we measure the element, meaning float and
The
what?
lever.
Level. Okay.
Level.
Yes, very good. Okay, so any question for this example, class?
No, madam.
Okay, very good. See, how about this one? Automatic control
Photocell.
system and used to control the degree of baking crackers. Okay, we go to industry and we see how to make a crackers. Okay, so meaning this system is to okay, the degree of baking cracker. Okay, who can give me the desired input?
Cracker color.
Okay, good. The cracker color. Okay, thank you, Mia. This is our desire input. Desire is desire cracker color. Okay, so student, you have to make your own block diagram, okay, from this system, okay. So you have to
Yes.
draw your block diagram. Okay, now our input is a desired cracker color. Okay,
Yes.
right. Okay, how about the next one, the controller? What is the controller here?
The conveyor belt.
Hmm,
Yung
what's the
with
controller here?
Auto.
No,
Signal conditioning.
Light source.
controller. So this is the,
Computer.
okay, very good. Okay, computer is our controller.
Oh, computer.
oh, okay.
And now
Yes.
conditioning circuit. Okay, this is the controller part.
Okay.
Okay, this is the controller part. Okay, and then how about our actuator?
Conveyor motor.
Conveyor belt.
Yes,
Conveyor
conveyor
motor.
motor. Okay, this is our actuator.
Okay.
Okay, and then how about after actuator? What
Plant.
element?
Line.
Plant.
Oven.
Okay, conveyor belt. Okay, because the motor will operate the conveyor belt, right?
Yes.
Okay, this is your plan. Okay, and then how about the measurement element or the feedback element?
Cell and light source.
Yes, very good. Okay, this is our feedback element.
Feedback element.
Yeah, this is our feedback element. Okay, right? Okay, everybody good?
Yes.
Yes.
Okay.
Yeah.
Okay, this is the answer for the baking cracker. Bake, degree of baking cracker. Or just now Mio cakap apa tadi? Color, color cracker or cracker color. Sama lah tu, lebih kurang. Okay. So the answer is input desired degree of baking cracker. Actual also same with the input. This one. Okay. This is sorry. Okay, the input and output is very close. Okay, the controller is the computer. Actuator, actuator signal conditioning circuit. Mhm. Signal conditioning circuit, conveyor belt and conveyor motor. Baking cracker. Wah, hold on.
Kenapa?
Baking cracker. Kejap ya. Madam tengok jawapan dia. Baking cracker. Oh, process. Okay. Meaning the process is oven. Sorry. Okay, this is your process. Okay, proses tu berlaku dekat mana? Okay, proses tu berlaku dekat dalam oven. Okay, oven is your process. Sorry class. Okay, oven is your process. Okay. Okay, oven is your process. And supposedly signal conditioning circuit is not actuator. Okay. So signal conditioning circuit is apa? Is controller. Okay. A signal conditioning circuit is we put together with the computer. Okay. Our actuator is this one. Our actuator is the motor and belt. Okay. And then baking cracker or oven. Okay, this is your plan. And then your transducer or your feedback element is a photocell or another one just now is a what? Photocell and the
Light
uh,
source.
light
Light source.
source. Okay, light source. Okay. Okay, and then from there we draw the block diagram. Okay, we represent the input the output, and then the output will be measured by photocell. Okay, this is a transducer. Okay, and then controller part, this one. Okay, signal dekat sini. This is a signal. Okay, signal conditioning circuit. Okay, and then this is a oven, meaning that they also say baking cracker. Okay, okay, this is just example for your exercise. Sketch the functional block diagram for the figure. The first one is a elevator. Okay, the first figure is the elevator system. Okay, the second one is the man or the operator is they want to control the water level inside the tank. Okay, the third figure is a travel cost. Okay, okay, how about this one? Temperature process control loop. How the temperature in the outflow is controlled using feedback control system. The temperature of water and steam. Okay, I give you 3 minutes to solve this example. To solve this exercise, 3 minutes. Okay, who can answer this example? Temperature process control loop. What what is our desired input?
Desired temperature.
Yes, good. Desired temperature, and then also same goes to the actual, right? The
Yes.
actual also is the actual temperature. Okay, and what is the controller?
The temperature control.
Okay, temperature control is our controller. Okay, this is our controller. Okay, and then our desire is our is temperature. Okay,
Yes.
and then how about the actuator?
Control valve.
Control valve.
Okay, okay, this is our actuator. Okay, and then the second part, the second element is the process.
Stream.
Okay, process. Where is the process happen?
Stream.
Okay, stream
Remote
or okay
control.
or pipe. Yes, good. Okay, meaning the process happen inside the pipe. Okay, this is the pipe.
Yes.
Pipe
Okay.
or stream. Okay. Okay, how about the feedback element?
Temperature
Temperature
transmitter.
transmitter.
Yes, this is the feedback element. Okay, very good. Okay, and you can see this is the answer. Okay, how to draw the block diagram represent the system given. Okay. Okay, so we finish our introduction about the control system. So how our discussion today? So far so good?
So far, so
Kena
good.
tengok balik.
Tengok balik apa, Syah?
Kena tengok balik recording sebab join lambat.
Ya, okay, tak apa. Nanti medium akan share di recording, okay? Ya, medium nak stop. Stop.